all this started when I found this video on number file channel, astounding 1 plus 2 plus 3 plus 4 plus 5 equals minus 1 over 12. And so I decided to work on this problem myself, and this is what I came up with. First of all, let's write it down. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and plus 8 plus 9 plus 10 plus 11, 12, 13, etc. And let's say it equals n, big N. So this is a sum of all natural numbers. And let's leave 1 alone here, let's not take it, and let's group all other numbers. Let me take red ink. So let's group them every 3 numbers. And let's look what it will give us. This group of 3 gives us 9. This group gives us 18. This is 27. And the last one is 36. Now, it is obvious that all of them are multiples of 9. So we can rewrite this sum as 1 plus 9 plus 18 plus 27 plus 36 plus 45 plus etc. equals n again. Now, why it is so, why we have a right to express it like this, is because every number is lower than the same number from next group, and it is lower, the difference between them is 3. And the difference here is 3 again. Now for the last number, obviously it is 3 again. So if we have 3 numbers in a group, and each number grows by 3, then the whole group grows by 9. So here we have 9, 18, 27, 36. Okay, let's move on. And now let's factorize this sequence of numbers. Let's take the common factor outside the parenthesis, and we will get 1 plus 1 plus 2 plus 3 plus 4 plus etc. Equals n. And inside this parenthesis we get the sum of all natural numbers again. It's n. Let me write it with red ink. It's n again. So let's rewrite it as a simple equation. 1 plus 9 n's equals n. Now we can solve it. It is very simple. 1 equals minus 8n, and n equals minus 1 over 8. Not over 12, as it is in that video. So by grouping all the numbers by groups of 3, we can get this result. It is very easy. It does not involve any infinite sequence of numbers, it's just regrouping. And you don't want to think, don't have to think about this sequence which which doesn't seem to be obvious what is the sum of it. If you watch that video, you know what I'm talking about. But let's do it again, but with different type of grouping. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13, 14, 15, 16, 17, etc. equals n. Now let's leave alone these two numbers, 1 and 2. Okay, and group 5 numbers. So these 5 numbers equal 25. Equals 25. Now here we get 50. You can check it. And the next one is 75. So they all are multiples of 25. And since we have 5 numbers in each group, and every number grows when we go from one group to another, and the difference is 5 for each number. So obviously every next group is greater than previous, and the difference is 25. So we can rewrite it as 1 plus 2 plus 25 plus 50 plus 75 plus 100 plus etc. equals n. Now let's factorize it. Let's take common factor outside the parentheses and get 25 times 1 plus 2 plus 3 plus etc. equals n. Now this group is just n again, so finally we get this simple we get this simple equation again. 25n equals n. Now this is 3 equals minus 24n, and n equals minus 3 over 24, which is again minus 1 over 8. Now let's do it again. Let's do it last time. Let's rewrite it. Let's say we leave alone 1 plus 2 plus 3. And let's group 7 numbers. 5 plus 6 plus 7 plus 8 plus 9 and plus 10. Okay, next group 11, 12, 13, 14, 15, 16, 17. 6 numbers, or 7 numbers again. So let's add all these numbers. 10, 30, 49. It's 49 here, and obviously since every number grows when we go from the first group to the second, and the difference is 7, and there are 7 numbers in every group, so difference between every group and its closest neighbor is 49, so here the sum is 98. Next sum will be 3 times 49, next will be 4 times 49. You can check it if you don't believe me, you don't have to, but I'm moving on and I can write it like this: 49, and now I'm putting them in brackets. I don't like parentheses because it's difficult to pronounce it if you are from Russia. Yeah, I take them in brackets, and it gives us n on the other side. And this group in brackets is n. Now we got 6 plus, move it up again a little, 6 plus 49n equals n, 6 equals minus 48n, and n equals minus 6 over 48 equals minus 1 over 8. Again, we got the same result. Now I want to get a little deeper into it and try to solve this problem for any number. 1 plus 2 plus 3 plus 4 plus etc. plus n. Let's say we leave alone group of n numbers, and then obviously we will start with n plus 1, next number, and then n plus 2 plus etc. plus some n plus m. Now in this group we have m terms, m numbers. In the next group we will start with m plus n plus 1 plus n plus m plus 2 and so on until we get to the end of this group. I don't want to think about how it will end, but finally it is also equals n. Now can we count, can we express the sum of these groups? Of course we can, and what we want to get here in this group, we want to get some perfect square, some b squared. Because, you know, if you noticed, in every case here we got a square. In the first case we got 9, which is perfect square of 3, and in the second case we got 25, which again is a square of the odd number. So I believe that if we try to find the sum of this group as a square of some odd number, probably we can find this n in general case. Okay, let's do it. So this is we have a simple formula for this type of sum, and so this is n plus 1 over 2 times n, this one. And this one is a little more complicated, but the formula is the same. So we have n plus 1 plus n plus m over 2 and times m. So our job is to show that this can be a square of some odd number. Okay, let's do it. So let's express it as a multiplication as a product of 2 n's plus m plus 1 over 2 times m. Now 2 n's we can divide by 2. Obviously it's m plus 1 over 2. M plus 1 over 2. So obviously we need m to be odd if we want this division here to end well, to get a whole number here. In order to get a whole number here, we want m to be an odd number. So m is an odd number. So probably we should try to express this product as a square of m, because m is an odd number. So if it's equal to m squared, then we are done. We solved this. So from here we can get this. And by doing some simple math, we can get that 2m's equals 2n plus m plus 1 and m equals 2n plus 1. So for any n, if we take m equal to 2 times n plus 1, we can express the whole sum as a sum of groups, and each group in this sum is equal to a square of some odd number, and they all are multiples of this n. Okay, now so we can rewrite our first expression as n plus 1 over 2 times n. This is the first term which we left alone. And now we have this group of m squared plus 2m squared plus 3m squared, etc. equals n. Why the next group is 2 times greater than the first group? Oh, it is obvious because every time we move from this group to the next, our number grows and the difference is obviously m. This number is greater than this number and the difference is m. Here, difference is m. And we have n such differences. So m times m is the difference between previous group and the next group. So if this group is equals to m squared, then this group is 2 times m squared. And the next group is 3m squared. Okay, now we have this equation, and let's factorize this part, and we'll get this m squared outside the brackets, and we'll get again we will get this sum of all natural numbers in brackets. Let me use red ink. I'm not sure if it will be if it will help in the actual video using red ink. So now if we replace it by this, and also I want to replace m after all, because I know that m is 2m's plus 1. Then I can express n again. Oh, sorry, it's not n here.
Телефон. Телефон.